how to find the particular integral if in the non-homogeneous linear differential equation u of x is of the type e to the power ax into v, where v is a function of x, and for that purpose we have seen one theorem. If we operate 1 upon f of t on e to the power axv, then this is equal to 1 e to the power ax operate 1 upon f of t plus a on v. We have seen this theorem last time, and also we have seen the proof of this theorem. We have seen the theorem 1 upon f of t operate on e to the power axv is equal to e to the power ax 1 upon f of t plus a operate on v, where v is a function of x, and we have seen the proof of this theorem. Now we want to see the example based on this topic. Means if u of x is of the type e to the power ax into v, then how to find its particular integral. Now see here the example. Solve the equation d cube minus 7d minus 6 of y is equal to e to the power x into 1 plus x. Now, as usual, first we find the complementary function to find the general solution of this non-homogeneous differential equation. For that purpose, we consider the associated homogeneous differential equation as to be d cube minus 7d minus 6 of y is equal to 0. From that, we take the auxiliary equation as to be m cube minus 7m minus 6 is equal to 0. Now we want to factorize this. The factor of this equation is m plus 1, m plus 2, m minus 3 is equal to 0. We know that how to factorize it. Now here the values of m are minus 1, minus 2, and 3. Therefore, we write the complementary function of this non-homogeneous differential equation yc is equal to c1 e to the power minus x plus c2 e to the power minus 2x plus c3 e to the power 3x. This is the complementary function of this non-homogeneous differential equation. Now we want to see how to find the particular integral yp is equal to 1 upon f of d operate on p of x, or this is equal to 1 upon d cube minus 7d minus 6 operate on e to the power x into 1 plus x. Now here, if we compare this with e to the power ax into v, then here a is 1 and v is 1 plus x. Therefore, by using the previous theorem, 1 upon f of t operate on e to the power axv is equal to e to the power ax and operate 1 upon f of t plus a on v. Here we take e to the power x outside of this operator and we substitute d by d plus a. Here a is 1. Therefore, in f of d, we substitute d by d plus 1. If we substitute d by d plus 1, then we obtain this is equal to e to the power x 1 upon d plus 1 cube minus d plus 1 cube minus 7 into d plus 1 minus 6 operate on 1 plus x. Now we want to simplify this. Then we get e to the power x d plus 1 cube is to be d cube plus 3d square plus 3d plus 1. Simplify this, minus 7d minus 7 minus 6, operate on 1 plus x. This is equal to e to the power x 1 upon d cube plus 3d square plus 3d minus 7d is minus 4d minus 6 minus 7 is minus 13 plus 1 is minus 12, and we operate on this 1 plus x. Now when we want to operate this on 1 plus x, we have seen the previous topic. When we operate 1 upon f of d on the terms of the type x to the power m, then we have to take the lowest degree term to be outside, and then we use the expansion of the type 1 upon 1 minus alpha or 1 upon 1 plus alpha and so on. Here we take the lowest degree term is minus 12. We take with the sign also outside. This is equal to minus e to the power x upon 1 upon 1 minus d cube plus 3d square minus 4d upon 12, operate on 1 plus x. And now we want to take the expansion by using 1 upon 1 minus alpha. We have written this 1 plus alpha square alpha cube and so on. Using that, the expansion of this is equal to minus e to the power x upon 12. We take 1 plus alpha is d cube plus 3d square minus 4d upon 12 plus alpha square means d cube plus 3d square minus 4d upon 12 bracket square. Means if we expand this, then we obtain each term is of order greater than 2, and the derivative of 1 plus x, its second order and higher order derivatives are to be 0. Therefore, we avoid that terms, and simplifying this is equal to minus e to the power x upon 12 in the bracket. We multiply this term 1 plus x by 1, means we get the first term is 1 plus x plus 1 upon 12. The third derivative of this is 0. Second derivative of this is 0. And derivative of this is 1. Means we obtain minus 4 upon 12. Means 1 plus x minus 4 upon 12. Means it comes to be 1 plus x minus 1 upon 3. This is our particular integral yp. And then we write the general solution from this. The general solution is y is equal to yc plus yp. We have seen the yc is c1 e to the power minus x plus c2 e to the power minus 2x plus c3 e to the power 3x minus e to the power x upon 12 into bracket x plus 2 upon 3. This is the general solution of given differential equation. Here we use the result, the 1 upon f of d, operate on e to the power ax b. Now we see one more example. Solve the equation d square minus 2d plus 5 of y or into y is equal to e to the power 2x into sine 2x. Now again, as usual, to find the general solution of this non-homogeneous differential equation, for that purpose we first find the complementary function. To find the complementary function, for that purpose we first take the associated homogeneous differential equation. From that, consider the auxiliary equation. We obtain here the auxiliary equation is m square minus 2m plus 5 is equal to 0. If we want to factorize it, there are so many methods. We rearrange this as to be m minus 1 bracket square plus 4, and therefore its factor is m minus 1 minus 2i and m minus 1 plus 2i. And therefore values of m from this is to be 1 plus 2i and 1 minus 2i. Here, roots are complex conjugate of each other and non-repeated. Therefore, to write the complementary function yc is equal to e to the power 1 into x, means e to the power x into bracket c1 cos 2x plus c2 sin 2x. This is our complementary function. Now we want to find the particular integral. To find the particular integral, yp is equal to 1 upon f of d operate on q of x. Here f of d is d square minus 2d plus 5 and q of x is e to the power 2x into sine 2x. Now again to operate this 1 upon d square minus 2d plus 5 on e to the power 2x into sine 2x. For that purpose, we use the result 1 upon f of d operate on e to the power ax into v. Here a is 2 and v is sine 2x. Therefore, we take this e to the power 2x outside of this operator and then we substitute in this operator d by d plus 2. Our a is 2, which comes from this e to the power x, not from this. This is our v, v is sine 2x. Therefore, we get this is equal to e to the power 2x, 1 upon substitute d by d plus 2, its square minus 2, d plus 2 plus 5 and operate this on sine 2x. Now we simplify the denominator. This is equal to e to the power 2x, 1 upon d square plus 4d plus 4 minus 2d minus 4 plus 5 operate on sine 2x. Again simplify this. This is equal to e to the power 2x 1 upon d square plus 4d minus 2d is plus 2d plus 4 minus 4 gets cancelled and what remains plus 5 and operate this on sine 2x. Now to operate this on sine ax or cos ax, we have seen that we substitute d square by minus a square. Again here a is 2. Regarding this result, 1 upon f of d operate on sine ax or cos ax. Compare it with that, here a is 2. Now here we substitute d square by minus a square, means d square by minus 4. Then we obtain this is equal to e to the power 2x, 1 upon minus 4 plus 2d plus 5 operate on sine 2x. This is equal to e to the power 2x, 1 upon 2d minus 4 plus 5 is plus 1 and operate this on sine 2x. Again to operate this, we multiply the numerator by 2d minus 1 and divide by 2d minus 1. We obtain this e to the power 2x 2d minus 1 upon 2d minus 1 2d plus 1 sine 2x. We simplify the denominator. This is equal to e to the power 2x 2d minus 1 upon 4d square minus 1. Take the multiplication, use the formula a minus b, a plus b is a square minus b square. Therefore, we get this is equal to e to the power 2x 2d minus 1 upon 4d square minus 1 operate on sine 2x. Now we operate first the denominator factor, means we operate first 1 upon 4d square minus 1 on sine 2x. And when we operate 1 upon 4d square minus 1 on sine 2x, we substitute d square by minus a square, means we substitute d square by minus 4 in the denominator. We get this is equal to e to the power 2x 2d minus 1 upon 4 into minus 4 minus 1 sine 2x. This becomes minus 16 minus 1 is minus 17 in the denominator. Then we get this is equal to minus e to the power 2x upon 17. And then we operate this 2d minus 1 on sine 2x. If we take 2 into derivative of sine 2x is cos 2x into 2 and previous 2, it becomes 4 cos 2x and minus sine 2x as it is, minus 1 into sine 2x. This 2d into derivative of sine 2x is 4 cos 2x and minus 1 into sine 2x is this. This is our yp, and from this we write the general solution as to be yc plus yp, and this is our general solution. We have find yc and yp, substitute these values, we obtain the general solution of the given non-homogeneous differential equation. Now we see the next example. Solve the equation d square plus d minus 1 of y is equal to 5 e to the power minus x into sine x minus 1. Again, consider the auxiliary equation m square plus m minus 1 is equal to 0. We know that how to find the roots of quadratic equation, minus b plus or minus under root of b square minus 4ac upon 2a. Using that result, you have studied this previously, therefore I have taken directly m is equal to minus 1 plus or minus root 5 upon 2. See here, these are not the complex roots, right? There is no I. This is not complex roots. These are the real and distinct roots. Minus 1 plus root 5 upon 2, minus 1 minus root 5 upon 2. That's why you that formula. Do not use the formula for complex or the result for complex. Therefore, our yc is equal to c1 e to the power minus 1 plus root 5 upon 2 into x plus C2 e to the power minus 1 minus root 5 upon 2 into x. This is the YC. I hope you understand this complementary function. Now we want to see the how to find the particular integral. Yp is equal to 1 upon f of d operate on p of x. This is equal to 1 upon d square plus d minus 1. Operate this on 5 e to the power minus x into sine x minus 1. Now 5 is constant. We take outside of this operator, then we obtain 5 1 upon d square plus d minus 1. Operate on e to the power minus x into sine x minus 1. And if we compare this with 1 upon f of t operate on e to the power ax into v, then here a is minus 1 and v is sine x minus 1. Therefore, using that previous result, we write this 5, we take e to the power minus x outside of this operator, and then we substitute d by d plus a. But here a is minus 1. Therefore, we substitute in this operator d by d minus 1. We obtain this 1 upon d minus 1 bracket square plus d minus 1 minus 1, and we operate this on v, means here operate on sine x minus 1. Simplify this. This is equal to 5 e to the power minus x, 1 upon denominator is d square minus 2d plus d becomes minus d plus 1 minus 1 gets cancelled and minus 1 remains. Then we obtain 1 upon d square minus d minus 1 operate on sine x minus 1. Now to operate this, you may separate this. We operate first 1 upon d square minus d minus 1 on sine x and minus 1 upon d square minus d minus 1 operate on 1. Now for the first term a is 1, we substitute d square by minus a square, means we substitute d square by minus 1. And for the second, we write 1 to the power 0x, and therefore we directly substitute d by 0 for the second term. Therefore, we obtain this is equal to 5 to the power minus x, 1 upon minus 1 minus d minus 1 operate on sin x minus 1 upon 0 minus 0 minus 1. Again, simplify the denominator. It comes to be minus 2 minus d. Therefore, we multiply the numerator by minus 2 plus d and denominator by minus 2 plus d, and then operate this on sin x, and the second term comes to be minus minus plus 1. I hope you understand this step. Now this is equal to 5 to the power minus x minus 2 plus d 1 upon, if we simplify this becomes minus 2, we have to square it, is 4 minus d square. Operate on sin x only, not on plus 1. Plus 1 is the separator. Now here again we substitute d square by minus a square to operate this on this. Means we substitute d square by minus 1. Therefore this becomes minus minus plus 1. This becomes 1 upon 5. We take outside of this, and this 5 gets cancelled. We obtain this 5 to the power minus x 1 upon 5, sorry, this 5 is a multiply 5 whole square bracket, not only this, do not cancel it. This is 1 upon 5 minus 2 plus d operate on sin x is minus 2 into sin x, and the derivative of sin x is cos x plus 1 as it is. This is our yp, and then we simplify this e to the power minus x. Take 5 inside, we get minus 2 sin x plus cos x plus 5. This is our particular integral. And then we write the general solution as to be yc plus yp. I hope this much example is to be sufficient for you. Now take the examples for practice. We have seen the 3 examples of this type. If q of x is of the type e to the power ax into v.